Hey everyone, Brian Beeler coming to you with the Storage Review podcast, and today we finally broached the technical issues and are bringing full video. And while we can't do this in person, we're pretty excited to have a guest from NVIDIA on today talking data processing units, not data power units. Anyway, Kevin Deierling joins us from California, out where it's nice and warm. How are you, Kevin?
Great to be here today.
All right, so let's start with the basics. I've even got a GPU sitting here, an RTX 8000 that we've been playing with. We're talking DPUs today at the highest of high levels. What the heck's a DPU, and how does it start to get different or interconnected with GPUs and CPUs and everything else in a server system?
Yeah, that's a great point. You know, I think everything starts with the GPU and AI. Because if you look at what's happening, every business is becoming an AI business. It's really the most powerful technology force of our time. And as part of that, we're seeing just massive growth in the complexity of these new deep neural network models. So whether it's for reading comprehension or medical devices or robots or cars, the amount of data and the access to that data and the ability to feed those GPUs is really critical. So CPUs are great for single-threaded applications. GPUs are great for really highly parallel machine learning and AI applications. And now there's this third new class of processors, which is the DPU, which is the data processing unit. And that really is fundamentally doing things that are different than the GPU and the CPU, and it feeds them with data.
So it's funny because obviously NVIDIA made a nice size investment in Mellanox, and of course Mellanox has been talking about all sorts of technologies on the NIC and their Bluefield technology and being able to drive more processing to the NIC. But I expected you to kind of go networking a little bit with that part of the conversation, but really in your world, the DPU can be on a NIC, but it can be other places too. So where does this thing get delivered? How is this packaged? And actually, I keep making the questions bigger, but how is this different than, say, like an FPGA, which has been a complement, especially in the HPC space, to GPUs within the server?
Yeah, so a lot to break down there.
Yeah, I apologize. I knew as soon as I started talking, it was getting a little too complicated. But I think these are all the fundamental questions that IT guys and scientists are trying to figure out. How do I architect the systems, and how do these pieces go together?
Yeah, so I think the key thing is we do start from our networking roots. So I was part of Mellanox and joined NVIDIA, early last year when the acquisition closed. And you're right, our heritage comes from our ConnectX family of NICs. And what the DPU is, it combines a ARM multi-core processor with our ConnectX NICs, and then a whole bunch of I/O connectivity through PCI Express. And we can put that all together on a SmartNIC. And that allows us to put a computer in front of the computer. And some of the things that people are doing in terms of building these SmartNICs, they aren't using what we would call a DPU. They can either use an FPGA or they can use some sort of customized processor. And if you look at it, we talked about our DPU being able to deliver the equivalent of 125 cores of CPU, x86 equivalent. Now, we have 8 or 16 cores on our DPUs. The naive approach would be simply to take the workloads that we're running on the x86 host processor and run those on the embedded CPUs in our system on a chip. And so if we did that, if that was our approach to DPUs, what we would find is that we would very quickly exhaust those embedded CPUs, because basically these single-threaded processors are not designed to do the types of workloads that a DPU can do. So we actually do it differently. We combine the DPU with our ConnectX adapters, which has a huge number of accelerators built in. So the key thing is we're not just moving the workloads off of the x86 CPUs and running them on the ARM CPUs. Quite the contrary, We're actually accelerating them. So we do offload, accelerate, and isolate.
Okay, so it doesn't have to replace FPGAs, or what's that relationship, do you think, long term?
Yeah, so in our view, the FPGA is a fantastic device to actually go off and do some prototyping. And we have devices that have FPGAs combined with our ConnectX adapters. And what we use is almost like a technology waterfall. So we've developed things like compression or security, encryption on those FPGAs. In some cases, they go into production. I don't want to say high volume production, but relatively low volume production. But very quickly, we can take those technologies that we've developed on the FPGA and incrementally put them into our ASICs. And when we do that, we get about a 30x to 50x area. An area in the silicon world corresponds directly to cost improvement. And so the FPGA is great for prototyping, but in the long run, we find that this programmable architecture with a ASIC and a combination of ARM processors and then hardware accelerators is much more efficient from power, cost, and performance.
So, okay, there's still a lot here to work through. So this is relatively new technology. Most of your cards themselves, I think they're all Gen 4 at this point. So you're able to take advantage of increased bus and PCIe lanes. But tell me more about the final packaged product and how, from an architecture standpoint, IT should be thinking about how to leverage these or how to deploy these, or when they're being asked by their data science folks about getting this latest technology into their systems. What are your considerations from a design standpoint?
Yeah, so I think I'll address the hardware side of that first, which in many ways is more straightforward. Okay. So effectively, the DPU is often deployed as part of a SmartNIC. And what that means is it's a NIC that you can plug into an existing server, preferably PCI Express Gen 4 based servers, to take full advantage of the bandwidth that's available. So we've got devices today that can do dual 100 gig or even 200 gig Ethernet or InfiniBand connectivity. When you plug that into a server, you've now put a computer in front of the computer. And that allows you to do this three things that I talked about, which is offload, accelerate, and isolate. And that isolation piece is really important because the acceleration is what people often focus on. And there you get, as I talked about, a huge performance increase. So typically about 30% of a data center CPU cores are consumed running software-defined storage, software-defined networking, software-defined security. And we can offload that and give that back to the x86 CPU cores to run applications. But the isolation piece is equally important because there we've basically moved the control path onto the DPU. And what that means is you can offer your customers, whether they're internal customers for a hybrid cloud or you're a public cloud and you're selling those cores to your customers, and you can sell a bare metal server to your customers and at the same time preserve all of the policies that you need in terms of data isolation, encryption, security, networking, quality of service guarantees. So that combination of offload, accelerate, and isolate is really the advantage of plugging a SmartNIC into a server.
Well, but just from a design standpoint, is it that simple? Just drop the thing in. I mean, you really need workloads that can benefit from it. But what would happen if you just throw it into some application box? Will there be any upswing naturally, or do you really have to be architected for these SmartNICs?
Yeah, in some cases, out of the box, you'll get all of the benefits without doing any changes to your architecture. Okay. And so there's a ton of workloads that are AI workloads that NVIDIA can deliver, or HPC workloads that we deliver and our customers build on top of it. In other cases, if you're looking at the traditional enterprise environment, all of the benefits are there. And the software integration is happening full throttle. So we made an announcement last year with VMware that we were
Right.
porting vSphere onto the SmartNIC DPUs. And once we've done that, then customers get all of the look and feel of VMware and vSphere and that management environment that they're familiar with. And we'll be able to leverage all of that on top of the DPU. So you'll get the benefits of the DPU with the full integration with VMware. And now we're doing the same thing in other environments like the Linux and Red Hat, Canonical, SUSE, so that you don't have to rip and replace. You can use things that you're familiar with and just drop your applications in, and they'll work faster.
Right. So the VMware integration is really an interesting one. I think it was VMware or VMworld 2. Well, last one was virtual. The last human VMworld. There was a lot of talk about integrating, virtualizing the GPUs. So now really talking about getting some of these emerging hardware components or advanced hardware components friendly with the hypervisor. That's a really big deal for your enterprise penetration, I assume. What are some of the other benefits? And if I'm in a VMware world, like I go back to how simple is this to consume, because that's part of the issue, right? Is what do I have to do? Every time we look at disruptive technologies, if they require too much manipulation, too much work, application rewrites, that kind of stuff, it just seems like they fall a little flat or adoption slow, or maybe doesn't happen at all. So what are you seeing there, do you think?
Yeah, I think you've nailed the key. Is if you actually disrupt the application flow, then there's a much bigger bar for acceptance of the new technologies. And this is actually something that's really interesting here, is that now we're running on this new DPU processor, and we've decoupled the application processor, hypervisor, and operating system from the infrastructure services that are running on the DPU. So if you've got software-defined security, software-defined storage, software-defined networking, now you've decoupled that from your application. And fundamentally, the application is looking at things. So if we look at the storage use case, we can do NVMe over local NVMe drives and support that on the DPU as if we have local storage. In fact, the storage may be remote. So we can present remote storage as if it were local in the box. And this gives you the ability to really scale out your storage. So you get elastic block storage that you can scale up, that you're no longer constrained by the size of your box, the number of PCIe slots that you can plug NVMe drives into. You can have as much storage you want in whichever servers you want, whenever you want. And from a software standpoint, the DPU says, you want a terabyte? Here's a terabyte of local storage. Behind the scenes, it can go off and access that storage remotely and then present it as if it were local storage. So there's actually some benefits here.
Well, very much a cloud methodology, right? Of provisioning storage, and how a lot of these hyperscalers get built. When you buy the cloud or the SSD volume, it's not going to be native necessarily to that box, but we've done a lot of work with NVMe over fabrics. We've seen some of the earlier solutions that were, Fusion IO was there with their SCST driver and putting that in the Ion box, and DSSD had tried that too, but that required a lot of complex PCIe switching and cards in every server that made it just a little too cumbersome to deploy. The promise, though, of being able to put storage adjacent to any application on any server within your infrastructure is pretty exciting. It still feels a little aspirational, but how far away do you think we are from seeing that in a more mainstream adoption?
Yeah, I think you're right to start with the cloud. Those have been the early adopters that have implemented this and actually got everything working, and they have the capabilities to do that themselves. So I think the question is when does this become available really for all data centers? Mm-hmm. And part of that is the work that we're doing with folks like VMware, folks like Red Hat, to make all of that available. In the world of AI, we already have that. So we've worked closely with our partners on the storage side, and we've done what's called GPU direct storage, where instead of sending the data into the CPU memory just sort of as a bounce buffer and then copying the data back from the CPU to the GPU, we can stream the data directly in with RDMA technology from the storage to the GPU. And there's incredible performance gains once we do that. And so we're already down that path on the AI side. And I think the enabling function that will deliver that to all applications is really the work we're doing with VMware, integrating RDMA into vSAN and other technologies. So that's happening, and we're excited because that will mean that you don't have to change the application, you just use it.
Well, and it simplifies the whole stack. And if we go back to the hardware for a minute, so we're talking about an edge card that goes in now. Any concerns about resiliency? Do I need a couple of these cards? How do I handle that? Because obviously, if I lose this card for some reason, then the workloads, lose the benefit of all that processing. What does the resiliency scenario look like for these NICs?
Yeah, so this is kind of a design decision that people can make. In the cloud, they look at it and they think, okay, well, our unit of failure is not even the server. They say it's a whole rack, or even a data center can go down.
Sure.
And so they have a different way of thinking about it. In other cases, we have people that want to put dual cards. So they'll put two of these into every server, and then they'll use two servers or two switches, top of rack switches, in every rack, and they build a full HA system that's fault tolerant within the rack. So any unit could fail, whether it's a cable or anything, and it'll still maintain functionality. That's really a design decision. The important thing there is we support both. So we're actually working and qualifying with our partners, our OEM partners, the Dells and HPs and Lenovos of the world, so that they have the capability to offer the customers whatever they want there.
Well, so thinking about the server then, we talked about Gen 4 a little bit. You must be excited then to be on the precipice of, obviously AMD's there already, but Intel's close, hopefully just weeks away. And that will open up even more slots for you. Go back to this Gen 4 and even Gen 5 if you want to look out down the roadmap a little bit. How does that help? Or is that really required? Was that a required technology step to really be able to bring this to a mainstream product like a NIC?
Yeah, so we're really excited to see PCIe Gen 4 become ubiquitous. We've had it for quite a while. People often ask, I don't have 100 gig in my data center. I don't think I need that. The reality is a single NVMe drive can saturate a 25 gig link. And with 3 of the most advanced NVMe drives, we can saturate a 100 gig link.
Oh, easy, sure.
So if you look, for example, at our DGX boxes, which is our AI appliance, we can actually drive 1.8 terabits out of that box. So we have 9 200 gig adapters. And to get that kind of throughput, you really need to use PCIe Gen 4. And again, this goes back to the problems that we're trying to solve need a massive amount of data, and there's a massive amount of communications between GPUs. So GPU direct storage and GPU to GPU communication can actually consume all of the bandwidth that we can provide. And PCI Express Gen 4 and hopefully soon Gen 5 is key to achieving all of that.
Yeah, and it's funny though, because you're not stopping at just putting these DPUs on the NICs. You've got a couple that you're looking at with GPUs on the board too. I know it's not designed to be as powerful as some of your other offerings, but tell me a little bit about that and what's the vision for this thing? Is it always going to be a NIC? It's almost its own little compute device that happens to have a couple 100 gig ports off the back end. I'm just trying to understand how much of this really remains to be a NIC after you've attached all these other compute products to the thing.
Yeah, so we've got a couple of products that combine the GPUs and the Bluefield DPUs onto a single card. One is our EGX, which really is both a Bluefield DPU is seen by the processor as well as the GPU. So it's almost like you get the functionality of 2 cards in a single card. And we also have something called the Bluefield 2X, which visually looks very similar. It has the Bluefield DPU. And with that product, we certainly can combine, the capabilities here of both the functionality, but the uniqueness there is that the DPU is actually controlling the GPU with our BlueField-2X product. So the BlueField-2X can do things like data integrity checks. It can do security, AI analytics, where it's looking at the stream of data that's flowing by and actually making calculations. So it's not a general purpose GPU. It's actually very much networking and security focused to work on the data as it's moving by.
So, I mean, you're talking about some of these use cases. I don't know how many publicly referenceable customers you have, but can you talk a little bit more about some of these use cases from a practical standpoint? If I'm an organization thinking about, I'm hearing about this tech, it sounds cool, sounds interesting. I get the world is all AI, but maybe we're not there yet, or maybe we're trying to figure out how to architect the next best way to do things. Do you have some good use cases you can talk about where orgs have put these in and experience some sort of acceleration or benefit or whatever other goodness they get out of these things?
Yeah, so I think we've got a bunch of different customers that are now using this in their data centers. We did an announcement with one of our customers in China who's using the capabilities of that elastic block storage that I talked about. So accelerating the storage capabilities over RDMA. So that's a critical function. We think we'll see a lot more here. So we've got lots of different customers. The other key use case that I think you'll see some announcements coming up is for storage itself. So if you look at the BlueField, it combines a ConnectX NIC and the embedded ARM processors and then the PCI Express lanes. Those PCI Express lanes can actually be used to control flash devices. So they don't have to be configured as a SmartNIC. We can operate as a controller where there is no x86 processor. And then you can build out a shelf that no longer has an x86. So the traditional storage shelves that we're in today are typically built on an x86 processor with a ConnectX adapter and then a bunch of flash. Mm-hmm. But now we can actually replace that. We don't need the x86 processor. We can just use the DPU with the storage controller.
So it would really be, the classic JBOD with several components, I guess, missing in terms of the control plane there.
Yeah, that's exactly right. It's a JBOF, so just a bunch of flash. And normally you'd have an x86 processor, you'd have a PCI Express switch, and then you'd have a bunch of flash behind that, and then you'd have connected to it a ConnectX or some sort of NIC that could do RDMA. Right. With the DPU SoC, we've combined that all into a single chip. So you can do everything you need, just put some flash there and you're done.
So what do you think that does for system designers? Because that flexibility, if you take that to Supermicro or Inspur or Dell, whoever, it doesn't make any difference. Now, most of these servers are sort of limited to 24 bays across the front, real traditional, because they've got all that other stuff in the box, in the mid plane, all the way back to the power supplies. JBODs are a little more spacious traditionally inside, as they tend to be a little empty or can be shorter or whatever. But have you thought about this from a density standpoint? What does this enable the storage vendors to do, server vendors in their designs, or are we a little bit too not there yet?
Yeah, I think that's exactly the kinds of things that the storage vendors are working through now. How do they take advantage of the fact that we've really, with this SoC, integrated everything onto a single chip? What does that mean for their form factors? We've seen people that want to double the density of the flash as they can now and offer more storage. In other cases, they're going to use the existing, models that they have. They're going to use the existing chassis, and they're going to use this to reduce cost, to reduce power, and to add capabilities like this RDMA and NVMe over fabrics.
So, yeah, I'm just thinking through the design, because now we've got the SSD guys wanting to do these high density ruler form factors that are increasingly popular. And it feels kind of exciting from a design standpoint, system design, because we're freeing up some of the technology, some of the data to flow over these high speed fabrics, to have these NICs with processing capability on top and whatever else is going on. It changes for the first time, maybe in a couple of years, the way we interact with storage. I mentioned Fusion IO before because we work so closely with them, but they were so disruptive in taking the FPGA, any flash that they could find, which at the time, they needed that flexibility because flash supplies aren't always great, as you know, and put that card in the system in a new way, where traditional storage was still pretty much front mount 2.5-inch SAS drives, and that card was so disruptive, and it took a while, and to see the adoption, and eventually they moved on to SanDisk and WD. But it feels exciting from a system architecture design standpoint. I mean, you guys are obviously feeling it with the NICs already. But what do you think? Do you see it the same way, or are we, still a little bit early in the plans for this?
Yeah, I really think that if you look at the IT vendors and you're trying to deploy things, you want as little disruption in your data center as possible. So that's why often if you come in, even with something that seems straightforward, a new form factor like Ruler, it actually takes a long time before that can be fully adopted, because in any reasonably complicated system, if you haven't tested it, it doesn't work. And so our goal here is actually not to drive the innovation on the form factors and some of these new capabilities. We'll let our storage and OEM partners do that. In fact, what we want to do is integrate with existing platforms and existing software and make the adoption of this just as easy as possible for CIOs and IT managers in their data centers, and just make it faster and better and more secure. So really our focus is not to try to take advantage and reinvent things and create new storage interfaces or anything like that. We want to just integrate with existing platforms and make it as easy as possible to adopt and get all the benefits that we can offer with isolation and acceleration.
So we talked a little bit about the VMware integration. That's going to be big to get you into the enterprise and potentially into SMB, or even, remote edge use cases. We're seeing even like that little SC350 I've got sitting on the desk. That thing came with a T4 in it and can do quite a bit of work at the edge in some of those surveillance use cases and others. Do you see, I would assume you do, this technology pushing all the way out to the edge, or does it get maybe too small out there? What do you think about DPUs getting outside the traditional data center?
No, I think they'll absolutely be at the edge for a couple of key use cases. You've talked about some of them, which is we have a platform called Metropolis, which is the smart city platform, which looks at a whole bunch of cameras. We have some precision timing capabilities on the device that can synchronize. So whether it's a camera feed or for 5G, you need very tight synchronization for a radio access network. And so all of those sorts of applications will drive the need for the DPU. The fact it can be a standalone controller is really important. Security is another huge element of the edge, so that in the edge, it's an unprotected environment. People will be plugging in things, and we need to authenticate and validate everything. There's not a security guard to protect your edge data center. That's something that's hanging on a pole somewhere. So we really have something that's built in with a secure root of trust into the DPU that says trust nothing. It's a zero trust model. Anything that plugs in there needs to be authenticated before it can come online and access the network.
Well, so what then prevents every NIC you sell? I've got Connect X6 sitting here that we're using. What prevents you from having one of your DPUs on every NIC you sell? Is it a cost issue, or do you think that over time we get there and every NIC is a smart data processing NIC?
Yeah, I think ultimately every NIC will be a smart NIC. Every server will have a smart NIC built into it, and because if you think about it, if you can get for the same, relatively speaking, the same cost, all of the capabilities that are built into the smart NIC, why wouldn't you? We're not there yet in terms of the price and the performance and the power, but we've showed a roadmap where we're accelerating the AI and the DPU together. That gives us 1,000x performance improvement over the next few years. And that's a combination of both architecture and silicon processing gains. So it's not just that we'll be going to the more advanced semiconductor process nodes, but also architecturally, we're adding new capabilities and new features. And so ultimately, if the premium here is relatively low, and we're eliminating the requirement to add, potentially 100 of CPU cores, then the cost pays for itself. So we truly believe that every NIC will become a smart NIC. Every business will become an AI business.
So can the silicon get small enough to be embedded on a server board so we're freeing up those PCIe slots, or is that too ambitious?
That seems to be a trend in the server world, that eventually when these things become so prevalent that you're putting it into everything, it becomes, they used to call it landed on motherboard. More and more, though, these are not really landed on motherboards. There's a mezzanine card of some flavor that allows you to put different form factors on there. And previously, a lot of the server OEMs built their own versions of these mezzanine cards. More and more, we're seeing adoption of OCP, which is the Compute Project. And that really gives you the best of both worlds. It's effectively landed on motherboard, but you can change it, and that way we have a pretty fast cadence that we invest in our new products. So you can see with our DPUs, our Bluefield, 1, 2, 3, 4, it's a very fast cadence. And so the ability for the OEMs to be able to go get the benefits of the latest, greatest DPU is important. So that OCP form factor is a very powerful one.
So go back to something you said about every business being an AI business, and I think a lot of that's true, and especially, I'm in Cincinnati. Procter & Gamble's just down the road. They are very much a data-driven business. GE Aviation, data-driven business. As you go further down the stack, and we've already talked a little bit about VMware integration, bringing this to the mainstream enterprise, which is great. If I look at SMBs, what goes on there? Can they take advantage ultimately of AI, do you think? And how do you strive to make it more attainable for small businesses that might say, if I'm in manufacturing, it's obvious. If I'm in certain other lines of business, I could see where if I had access to this information and could process it and do something with it, that would be great. But data scientists are hard here in Cincinnati. It's not like they're falling out of the trees like maybe at the more technical schools in the Northeast and out West where you are. But how do you talk to small businesses about AI and what they can do there?
Yeah, I think you've nailed the question. And it's really what gets me excited. When I joined NVIDIA, what I realized is this is not a component company. This is an AI platform company. And we don't want every business to have to become experts in AI and, data scientists to go off and develop new deep neural network models. So what NVIDIA has done is invested in a huge number of platforms. And a platform is something like Clara. So you mentioned J&J. We have a medical platform, and whether that's for drug discovery or medical devices or imaging or pharmaceuticals, whatever it is, we have done the heavy lifting to develop the models. So what we're asking customers and partners to do is reach out to us and leverage the work that we've done. We don't want them to become AI experts. But what we find is that whatever business, whether it's a retail business or robotics or manufacturing, drug discovery, whatever business it is, it can benefit from AI. And we're investing in the software platforms. So we just need to go in. Our partners, our customers have the business expertise, and they can deploy that on top of a model that we've developed. They don't need to be AI experts. We want to provide that platform to them and take advantage of their business expertise.
All right. Well, yeah, you mentioned J&J. I said P&G. You're talking, science stuff. I'm talking Tide Pods. I don't know. It's all data though in the end, and it is really interesting. What you can do and the insights. Actually, I did a pod a couple of weeks ago with one of your education customers, partners down at University of Florida. And while they're not using these SmartNICs yet, I don't think, maybe in their data center, they're building a big HPC setup. But this one was specific to the citrus crop in Florida and using these sprayers and drones, and they're leveraging the little Jetson boards. But I mean, it's a remarkable, even at the micro level. We talked edge. I was thinking servers at, edge data collection devices like these drones. And the analysis that they're doing in real time is super cool. And they're part of the NVIDIA Accelerator program, which I think a few weeks ago hadn't even been terribly familiar with it. So the enablement there is really cool from a services and support standpoint. So do you guys have an org built? I mean, obviously I talked about the accelerator program, but an org built specifically to consult with businesses trying to figure out how to get at these problems?
Yeah, so there's our Inception program, which is really what you were talking about, where we start with work with smaller companies. But for each of the different workloads, so yeah, you're right. I played letter alphabet soup there with E and G. The great thing is if you look at a company that's really a retail-oriented company, we have a whole retail platform. So we have a recommendation engine system. We have natural language processing. That's our Jarvis platform, and Merlin is our recommendation platform. So whatever the business is, we will have a platform, and we'll have a point where you can engage with our experts that have developed those AI platforms. And what we'll do is work with businesses to apply their business expertise on top of that platform. So we've done a lot of the AI heavy lifting, and now the work is really to apply the business know-how and the advantages that each company can bring to bear, and then accelerate that and do things that really couldn't have been done before, solve problems that were impossible to solve.
Well, certainly the more you can modularize these components, which is clearly what you're working toward, it would be pretty remarkable to be sitting in my vSphere, control center and say, okay, well, we want to do this with this application. Let me pull the NVIDIA libraries and the components and put these blocks together. Maybe it's in a container, maybe it's a VM, whatever it is, and piece that stuff together like Legos would be pretty earth-shattering, I think, in terms of bringing AI to the masses. And that's one of the things that I'm always thinking about is, if you're a big city or a big company or whatever, you've got the budget and the resources to go make these things happen. But how do we democratize AI to the point where smaller manufacturers, smaller retailers, and if we've learned anything through all the trouble COVID has caused, is that being dynamic makes all the difference in the survivability of your business. So, that's the genesis for some of those questions is to get at how do we keep going and keep pushing this out there to more than just the gigantic players.
Yeah, so I think you've just nailed one of the challenges that we have is automation. And so the things you talked about having a library of platforms that you can plug in to build systems and then do that dynamically, potentially on containers, that's an area, again, where we just don't want to tell our customers, oh, go build that. It turns out that a really complicated thing to do. So we built that as well. So we have something called Fleet Command, which is really, if you think about a fleet of cars where you just go in and you get the rental car you need and you use it and then you bring it back and it goes away. So we've automating all of that with our Fleet Command that actually allows you to go pull containers, pull platforms, use what you need, bring it up, run some workloads, do what's needed, dynamically expand that as you need to, and then turn it off when you're done. So we think that that's something that in the hybrid cloud, in the public cloud, that they'll be able to take advantage of.
Well, yeah, that sort of ephemeral notion is very core to the way apps are being developed these days. This whole test dev motion that's become so popular over the last couple of years, and even I was talking to some of the guys from Roblox, and they were talking about how containers for their matchmaking for all the people that are home. I almost said kids, but I know a lot of adults are there too. Are playing these games and having these containers to set up their matches and putting people together based on the game and the geography and all these other variables has fundamentally changed the way their business works. So it's certainly the direction in the motion. When we started, I talked about how these DPUs sit in a system adjacent to CPU and GPU, and I just want to go back and maybe tie that up a little bit tighter. You very much see these as being complementary to those technologies, and I presume you've got customers that are building boxes still both with these DPUs and GPUs adjacent to each other. From an architecture standpoint, how are you balancing GPU versus slots versus DPU slots, and what else is going on there with the GPU? I know you're not the GPU guy, but how's the balance between GPU being impacted by these?
Yeah, so You're absolutely right. These are complementary technologies. So the CPU is really good at running single-threaded applications. The GPU is fantastic at running accelerated AI applications that use massive parallel processing. And the DPU feeds both of those other two devices. And it's a data processing unit. So something that is highly packet intensive, networking intensive, security, compression, touching every packet. And so they're very much complementary. I think what we see is as the amount of workloads is being shifted to GPUs and DPUs. I mentioned with the DPU, we can deliver the performance of 125 CPU cores. It really requires a different way of thinking from the server vendors. And so we actually are a consumer of our own device here, that with our DGX, where we have all three of those. We have CPUs, DPUs, and GPUs all in the same box. And what we've done is architected it to provide the power and the cooling. If we're going to be delivering a massive amount of performance, we really need to change the way some of these boxes are architected so that you have the power and the cooling to be able to support the amount of capabilities that we have. As I mentioned, we've got 9 PCIe slots inside of our DGX that's delivering 1.8 terabits per second of performance and throughput. We really need new platforms that can support this new balance between CPUs, GPUs, and DPUs.
On that DGX thing, though, can you play Fortnite on it? I think that's really the main question here that everyone wants to know.
Yeah, well, the funny thing is, we consume our own technology. That's another thing I love about NVIDIA. We eat our own dog food, we say. We have gaming platforms that actually are deployed in the cloud. And we can do a massive amount of gaming on these new Ampere-based platforms that we have with DGX.
That's pretty great. I want to see the clustered Fortnite that you guys are running and see what that looks like after about 5:30 at the NVIDIA HQ once everyone's back together. One other thing, though, I wanted to bring up, because you made a really interesting point earlier about connecting storage to the card and providing sort of proximate access for the application to storage, regardless of where it physically sits. One of the other things that's coming up more and more are these sort of computational SSDs. Samsung's working on it. There's some others. What do you think of that model, I suppose, in terms of putting some compute adjacent to, well, in their case, inside the storage enclosure itself?
Yeah, so generally, we think the DPU is fantastic for doing that. And the reason is because it's a general purpose programming CPU, okay? We can do anything. You tell us what computational workload you want to do, we can do it because we have this programmable model. And if you contrast that with something that's been integrated into the storage device itself, usually it's a fixed function device. And what we find is that you can never get it perfect. You'll always need to extend it with some new capability, there's some new algorithmic development, etc. And so the storage industry tends to be very, very slow to adopt new interfaces.
You wouldn't say.
Yeah. So, I worked on what eventually became NVMe, NVMe drives back starting in 2007 with the startup. It was, and you look at how long it took before NVMe was adopted. So I think NVMe has a long run in front of it. I think if you want to do something like we're doing today, where we have all kinds of different algorithms, even file systems that are running on the DPU, that's the right way to do algorithmic storage and use the mass volume of NVMe. You'll get much better pricing than if you're using some sort of custom computational storage block. Now, we do work with all those partners because we love them.
Sure.
They're great and they use our adapters often.
Well, it depends, too, on your philosophy, I think, in terms of where you want this data processing to happen. Where does the storage live? If it lives in the server, then compute at the drive level makes some sense. If it's shared or in a JBOF, then obviously on the other side of the NIC makes some sense. So there's just a how do you do it? What mix is the right mix kind of thing, too, right?
Exactly. Yeah. And in some cases, I think those computational storage boxes will be based on the Bluefield DPU. So that'll be a great way to do it as well.
All right, it was DPUs everywhere. They're coming. They're available, but there's integrations are coming. There's all sorts of solutions coming. Kevin, this is awesome. I appreciate you Skyping in for this and giving us a little bit of a masterclass on DPUs and how they're part of the next generation.
Likewise, I appreciate the chance to talk. It was great.
Awesome. Thanks, Kevin.
Thanks.